What is up, Mr. Labor? Today I'm going to be giving a presentation on the effects of microgravity on the musculoskeletal system, and I'm going to do 2-in-1. I'm also going to do the Mars mission too. So first up, what is normal gravity? What does it do to the body? So normal gravity, or 1G, is what the human body's evolved to function under. Bones are dense, and they support the weight of the body and the Earth's pull. The muscles and tendons and all that stuff and joints. That's what helps your body, move around. In older age, humans can experience muscle mass loss and arthritis in joints, just because they're getting old. So your bones, what happens to your bones in space? So studies show that decreased bone mass and density while in space, and further testing of astronauts shows that they never really get that bone density back, which kind of sucks. It's not like a muscle. So your muscles. So what's the deal? What's going on with muscles? So muscles are shown to atrophy in space. It's kind of like if you just lay around in bed all day for a really long time, which is kind of like what we're doing now in this quarantine. Once back on Earth, astronauts usually gain their muscle back because it's just a muscle. It'll grow back. It's pretty stout. Pretty resilient. Joints and ligaments. So joints and ligaments are probably the worst parts, shares the worst parts of bones and muscles. So, like muscles, they deteriorate pretty quickly, but they don't come back in full strength like bones. Astronauts have been shown to have arthritis in their joints and ligament and tendon deterioration while they're in space. Basically, you're just getting older, but faster. Physical preparation. Astronauts usually exercise pretty good. They're in good physical condition, so that way once they go into space, they don't, they can function. They also take trips in airplanes that do high altitude arcs to simulate zero gravity. So what they do is they go really high up in the sky with their planes, and then they nose down, and basically it's just a really controlled fall. And since they don't have any air resistance, anything inside the cockpit, it's kind of like skydiving, but it's like zero gravity. And that kind of helps them, get their bearings and get used to what it's going to be like when they're in space for a couple months. So atmospheric conditions. So bones and tendons aren't really affected by atmosphere because they're covered up. However, with less oxygen in the air, like high altitudes, your lungs can't really quite provide that much oxygen to your muscles. So kind of like if you've ever been like skiing or something, you've been up on the top of a mountain and you try to move around, the air's a lot thinner and you run out of breath a lot faster. And you just can't really get around like you want to. Extended exposure to microgravity, so it will result in muscle atrophy, breakdown of bone density, and deterioration of ligaments and joints. So going to Mars, it's where it gets cool. Our main objective in this mission is fly to Mars, do a few orbits, and come back. We'd go to the surface, but that's expensive, and it's expensive enough getting all the way to Mars. So crew, who's going to Mars? We're going to have 4 crew members. They're all going to be male because peak physical condition, it's just how it is. How they did it before when they went to the moon. We want them to be in between their 30s and 40s, in really good health condition, obviously. And the crew will comprise a pilot, a doctor, an engineer, and, someone who's doing some good old research on Mars. So crew function, so your pilot, is in charge of getting your ship and his crew to and from Mars. In charge of like all the navigation goodness. You got a doctor, in case he's in charge of making sure everybody stays healthy. In case anybody got anything medically going on, and take care of it. Also, they can do some research on how long extended like space travel affects the human body. Engineer, maintain the ship, maintain all the instruments used to take tests on what's going on. Maybe do repairs in case of emergency. A researcher, take data on any tests or probes that are sent out and anything done in space. Will be the least crucial member on board, so if they get stuck and they get to eat somebody, they're eating the researcher. So trip time. So trip time would be roughly 6 to 8 months. As you can see here on this graphic, Mars orbit is a lot further out than Earth, so the spacecraft would have to leave Earth and then slowly make its way around to Mars and intersect with Mars orbit, and that's when it would intersect with Mars at a certain date. And then once they're ready to leave, they would also have to take a curvature similar and then intersect back with Earth once they reach Earth's orbital path. So surviving zero gravity, we make discount gravity. So while it's not real gravity, centripetal force might be the answer to zero gravity. It's considered a force by which bodies are drawn or impelled or in any way tend towards a point as to a center. It's from Isaac Newton, so that's why it sounds weird. Think about like when you're going around a car, like a corner in a car really fast. If you like just yank the wheel, feel like you get sucked to the outside of your car door. The car door pushing back against you, that is centripetal force. And so, you know, if you had a space station that was turning really fast, like spinning like in a big circle like that, it'd be a similar effect. Like the walls of the space station pushing up back against you from, you know, flinging out. That would be kind of like, you know, simulated gravity. So if we had simulated gravity or just centripetal force, you know, how would this affect the body? So gravity on Earth forces the body to use its muscles regularly. This prevents muscle breakdown, tendon breakdown, joint breakdown, loss of bone density, you know, the good old stuff. Simulated gravity would prevent severe deterioration. So the crew members would probably be able to function better under more Earth-like conditions also. I think this would also be important, you know, if you're going to stay in space for 6 to 8 months, it'd be nice to have some gravity. So there's my sources. Thank you for listening to my late presentation.